Raz, dwa, trzy, cztery, pięć, sześć. Raz, dwa, trzy, cztery, pięć, sześć, siedem, osiem.
Chyba się ogarniemy. O, jest, Piotrze, działa. Super. No szybko. Okej, a teraz jeszcze jak wyłączę i włączę jeszcze raz. Jeszcze raz sprawdzam. Działa. Działa. Czy ja mówię cicho? Czy tam na końcu mnie słychać? Halo? Dobrze. Nie? A teraz? O, teraz chyba lepiej. Dobra, to już wiemy, że musi być blisko twarzy. Okej. Ponieważ dzisiaj mamy wszystkie toki po... Aha. O. Cześć. Ponieważ dzisiaj wszystkie toki mamy po angielsku, to zaprosiliśmy Barry'ego jako dzisiaj Mastera of Ceremony. Welcome, Barry! It's your turn.
Maybe this one. Oh, can you hear me now? Welcome, everybody. Proszę, zapraszamy. 2 words po polsku, dzień dobry, and that's it. The language is extremely difficult, so I'm very pleased to be with you for the 60th WarsawJS Meetup. Is that correct? Yes. 60 times. Bravo, everybody. Unbelievable. So how many of you have been here, are here for the first time? Anybody for the first time? Oh, okay. Dzień dobry, witamy, witamy. No Polish, because my Polish is so terrible that people start to laugh when I start speaking in Polish. So, my name is Barry Solone. I am a native speaker. That's funny already? Okay, good. I'm a native speaker and also an entertainer. So I am what you call the VA in VAT. I am the VA in VFT. I am the added value, basically. That's what that means. It's really a pleasure to be with you guys. I'm very, very impressed always with this community that you have of JavaScript programmers and coders. It's something I know nothing about, so please forgive me for my ignorance. The whole field that you are in, for me, is very impressive. And I'm really happy to be able to be with a crowd, a community of people in Warsaw, exactly, who are so forward in the field. So congratulations to you all. Before we begin, I first need to make mention of the sponsors of this event. And those sponsors are, and you can clap at any time. In fact, clap continuously. Are, thank you, I need that. 10 Clouds, Daft Code, Sumo Logic, and Schedule. Schedule, that one was a little bit difficult for me because it sounds like someone trying with a British accent to say schedule. Right? Exactly. How many of you speak English fluently? So everybody is fluent in English. That makes at least my job a little bit easier. This is not my first time, but I thank you for welcoming me to this community because you guys as a community are very scary. Scary why? Scary because you're very analytical, very logical, very intelligent. I just wear these glasses because they make me look more intelligent. But in fact, I am just really, as soon as you start to talk about technical issues, I will be completely lost. So for me, this is also an opportunity to learn a little bit about what's new, what's happening in the field. Okay, is this my better light? Can you see me better now? That's the thing. Okay, first I need to remind everybody, and this is important, especially if you're here for the first time, that WarsawJS ascribes to the Berlin Code of Conduct. The Berlin Code of Conduct means that under no circumstances will abusive or discriminatory behavior be tolerated. So that means that we're very welcoming and also encouraging to all of the participants in terms of their participation, in terms of their simply being here together with us, which is part of the reason that I'm here. I'm actually a living example of the Berlin Code of Conduct. I mean, this is what is happening. So that's why I'm really thankful to people for observing that code of conduct and to being not only polite, but being welcoming and engaging with all of the other participants. This December, I have to follow these slides, I see. Okay, you're with me on this. We will be having the WarsawJS meeting at the end of this year, and I've been told, yes? And it's a conference, that's correct. This is a big conference. I was there last year, that was my premiere, my debut, if you will. And it was, of course, really, really nerve-wracking for me, but it was a great experience for me, and that's why I'm here again, because I said, wow, this is really cool. It's not only a room full of men, as I had anticipated. I thought it was just going to be all googly-eyed, nerdy men. But then I noticed that you have quite a few ladies in your community, and I think that's great. As I said, I also met people from Israel, people from other countries, and it was really exciting to see what's happening here in Warsaw. I've been asked to tell you that if you buy your pre-sale tickets for this event, that's from today and for the next 5 days, that you will get a 60% discount. 60% sounds like a lot to me. I don't know how that sounds for you, but it seems like a good idea. So if you're interested in buying the pre-sale tickets, this is not pre-sale, but pre. This is even hard in English. Please go to the link, which is WarsawConfront.com. ConfrontJS.com. That's where you can find a link where you will be able to purchase your tickets in advance. Beyond that, I just need the names of the speakers because I don't have it in front of me. Are we there? I'd like to now finally invite, our very first speaker. Oh, there he is. And this is, okay, so when I start pronouncing names in Polish, please don't laugh at me. I'm pretty good with names, but not in every case. This is Grzegorz Tańczyk. Did I do it? Is it okay? Thank you very much. And he's going to be speaking to you about a very important topic. So Grzegorz, are you here? There he is. Welcome him to the stage. Thank you very much. Should I keep it or take it? Each speaker will have 30 minutes to present. Again, I'm not a presenter. I'm just like a thing, so I can't call myself presenter. This is a real presenter and a real speaker. Którego? Krzyszek? Oh, the first one here. Krzysztof Trześniewski, because I'm so sorry because I announced you because you were the closest to me. Krzysztof Trześniewski, dobrze mówię? Whew, thank you very much. You'll have 30 minutes. Everyone will have 30 minutes. If you hear this, it means you have 5 minutes, okay? Super. Thank you very much.
Raz, dwa, trzy. Świetnie. Okay. Hello, everyone. Whoa, so many faces. It's great to welcome you on the 60th WarsawJS Meetup. Today I will be talking about testing observables. My name is Chris, and let's just get started. So, first of all, I would like to start from some basic concepts. So, why do we actually test our code? First of all, it gives us confidence that what we did right is actually doing what we wanted to. And the next step coming from that is that we can maintain our code better. So if we want to refactor it,
we won't be afraid to do so. So if anyone here ever was afraid to touch some code, it might have been because it wasn't tested well enough. So testing can prevent that. And the next thing, that if you work with test-driven development, it acts as a guide for you. So you write test first, and then this kind of gives you how your code should behave, and you can fail and pass the tests you write over and over again. And the final thing is that it is basically a documentation of your code. So the next developer will know what actually your code does, and it's kind of a smallest example of how you can use it in other parts of your application. So we've got why covered. So let's go straight away to how do we test. So with the I will start with the most simple example I can imagine. So a multiply function. If for some reason we want to test that, we can do that, and we can choose a lot of testing frameworks. Most of them will have syntax similar to this. So we provide a test suite with the describe wrapper, and then we put individual tests in the it function. So our multiply function should calculate properly. So how do we test that? We provide it with the input and expected output, and then calculate, run our function with the input, and compare if the result is equal to the expected value. And in this case, it passes, so we are happy. And can we test observables the same way? So I created a small example with the not null operator. So if you have an observable, a stream of data, it will only emit, after applying this operator, it should only emit values that are not null. So it will basically filter null values. So let's test that quickly with the same approach as we did with the multiply function. So we create our source. From is just a helper function to create an observable from an array. Then we create our result observable with applied with not null applied to it. And then to test what comes out of our result, we create a spy function. And because observables are lazy, we need to actually subscribe to check what's happening underneath. So we subscribe to our result, and we expect the spy to be called 2 times because the null should be filtered out, and to have been called with 1 and 2. So this works, exactly this test. And so are we done? Well, that would be cool, but not really. So let's come back to what observable actually is. So this is a diagram representing that, and how I like to think of it is that it's data delivered over time, and that part over time is really important because it can be synchronous, and in the example I have shown you, it actually was. But most of the time it won't be, and it will be asynchronous. So we need a way to test the asynchronous behavior of it. So let's write a second test, similar to the previous one, but the difference is that by default from will emit all the values right away because it's synchronous. But we can provide it with a different scheduler, which will basically schedule it for the next tick so it will basically run it asynchronously. And the rest of the code is the same. And in this case, the test fails. So what happened is actually that when we subscribed, no value was emitted yet, so our SPY didn't actually get called at all. So we need a way to work around that. So the first way to do so is pretty similar to what we used to do with testing promises. So the difference here in this scaffolding is that we have a whoa, that's wrong. This only this done should be here. I'm sorry. So we've got a done function here, which will notify the test runner that our test is finished. So first 3 lines are the same. So we have our source with 1, null, and 2, and we've got a result which filters out null values. And we create a SPY as we already did. And now we need to subscribe a bit differently. So the previous syntax was a shorthand for just calling next function, which basically is called when we emit new values. But now we actually want to know when our observable is complete. So when it emits all the values, it will emit another event called complete, and when it happens, this function will be called. So we can move our logic from the synchronous example to this one just inside of this function. So let's do that. Now we expect after the result is complete, we expect it to be called twice with value 1 and 2. And now we can call our done function, which will notify the test runner that we are done. So this test passes. So yay, we are happy. But what are the pitfalls of this approach? So well, we need to be aware of the when the observable is complete, and some of the observables are never completing, so we kind of need to work around that, and it might be hard to do so. Secondly, the test can take long. So imagine that our test wasn't just taking one tick to execute, it would be delayed for a few seconds. It will take those 3 seconds to execute. So and even test runners by default have a limit of 5 seconds, after which it will time out. So it's kind of not, we don't want that behavior to be there. And this is the example of the delayed source. And in this case, the previous test will take 3 seconds and few milliseconds. So if we have multiple of those running, it will probably prevent us from running those tests all the time, which might cause us more bugs, more fixing in the future. So how can we handle that more neatly? We can use fake asynchronous tests. So how do we do that? So what's happening? Sorry, I forgot to. Okay. We need to wrap it with the fake async function, but it's not shown here. Apart from that, it's a good example. So the first lines are the same, and then we just subscribe with our SPY. And now we can just use a tick function, which will basically mimic the behavior of time passing. So at first, we expect it to not have been called because it's delayed. But after 3,000 milliseconds, which we pass with the tick function, we expect it to be called with again twice and with the values provided. So again, it passes. And what are the benefits of fake async tests is that they are synchronous. So we don't have the we can manage how the time passes more easily and test what happens after that. And we have full control over time. So the test will actually run just 50 milliseconds or something like that. And so it's fast. So we don't have a downside of waiting 3 seconds for it to execute. But we have a nicer way to test observables. There is a library for doing so, which is called, the concept is called marble testing. And the diagram I've shown you before with the stream of values was basically a visual representation of our stream. And with marble testing, we kind of doing the same, but in our IDE. So it has a visual representation in the tests themselves. It's more intuitive because we can look at the observables and visualize how it works. It's fast, just as fake async was. So let's have a look how we can apply that. So the only difference, the one difference is that we need to wrap our testing function with the marbles wrapper, which provides us with the marble testing context, which will allow us to create and assert observables. Can I have some water? Okay. So this is the part where which I talked about, that we can kind of see how our observables look like. So here we define our source observable, which will contain x, y, and z, which will map to 1, null, and 2, as we had in our previous example. And the expected result is just 1 and 2 at the time specified by the visual representation. So if the source had a value at this time, we expect it to occur at the same time in our result. And then we, with the context, we can create our observables by calling cold. The difference between cold and hot observable is well explained by my friend Natalia Tepluchina. If you are interested, I can direct you afterwards. So here we create our source and our expected results. And because here we used x, y, z, we need to actually provide a mapping for what those stand for. So here x stands for 1, y stands for null, and z stands for 2. And then we just create our result as we already did before. And now we can use another function from our context, which is expect. And then we just expect result to be the expected observable. And that's basically checks when everything happens, if all the values are emitted at the same time, if they are the same, if they are completed at the same time, etc., etc. And this test basically passes. So I think I have some time for some more examples. So let's go to our visuals to our web store. So here I have and maybe I will start with the marble testing example first. So we have our is it I don't know. Not this way. Is it big enough? Okay. Ooh. Color scheme. Default. No. Okay. Is it better? Okay, so we have our source, which emits 1, 2, 3, and 4. And I have created a buffer delay function, which basically what I wanted to do to maybe it will be easier to write what is expected. So we expected it to have emit 1 right away, then wait 5 milliseconds to emit the next value, 1, 2, 3, 4, 5, and then emit wait another 5 milliseconds to emit 3, and then wait another 5 milliseconds to emit 4. So it kind of spreads the emitted value. It acts like a dam. So whenever we can, for example, click the button how often we want, but it will emit all the clicks at some point, but they will be spread evenly by the time we specify here. So, and then we expect it to end. I did wrap it with, because those will happen at the same time. So we will emit the 4th value and finish right away, because this stream already have finished. If we made it a bit longer, we could expect it to be like this. So we can start with that. And it should fail. That's the beauty of live coding. How do I come back? Buffer, lay spec. Maybe I should try. Haha. Okay, I didn't write any assertions yet. Okay, so now we just expect our result to be observable expected. Please fail. Yeah. Okay. So our code failed, and now we can switch the implementation to the one that is actually working. And okay, it works. But let's imagine that we want it to work a bit differently. So we had our end complete here, and we want to, if our source observable completes, we want our result to complete right away. So this is our expected behavior. Fails again, yay. So this kind of helps us model our behavior. So we can visualize how it works. And this helps both us as developers writing the code and the future, maybe our children will have a look at our code and not blame us for being douchebags. So let's fix that. Const done. New subject. So now we can work in the test-driven development way and try to fix our failed code. So we just need to make sure that when our source actually emits a complete, we want it to be finished. So let's make sure that that happens. We have a operator for calling a function when the observable completes, which is called finalize. And we just push to our done. Okay. So what happens is that whenever our source is complete, we push to another observable, which is called done, and then our whole observable is take until operator is applied to it, so it will make sure that it ends at that time. So now our code is successful. So I don't know if I have still 5 more minutes. Maybe yes, I didn't hear the bell. So let's go back to our spec. So we can write similar stuff in our previous ways, but because we just change the behavior, it will basically act as it completes right away, because this is just a synchronous stream, so it will emit 4 values and complete right away. So let's go back to our previous implementation. This is enough to just comment this out. And how can we do that with our fake async way? So let's focus here. This is done. Okay, this should pass because there's no assertions. But we can create our spy, const spy, create spy. And as we did before, we just subscribe to our result with a spy, and then because this was emitted right away, so we expect it to be called right away. So expect spy to have been called once. Again? Okay. No worries. To have been called, yep. And expect actually there is a better way. So const, we just save current value. And not const but let. No vars, please. Okay, so now we can just expect our current value. Okay, I have 5 minutes, I can make it. To equal 1. Then we can, so let's see that it still passes. Okay, it passes. Ooh, it doesn't pass. Awesome.
We have 5 minutes.
La 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 la. Awesome. Yeah, that's useful. There's okay. We just need to make sure that we flash everything. So let's just and what? Not here. Here. Okay. Okay. We had to make sure that our result stream is finished. So we just make sure with tick to actually 4 seconds would be enough, but so we expect the value to equal 1. Then we can tick, damn it, tick 1000 milliseconds and expect our current value to equal 2. And let's duplicate that twice. 3, 4, and it still passes. If we expected it to be 5 here, it will of course fail. So let's go to the final one. So here we actually need to provide some kind of helper observable to help us test what happens on the way. So I call it timer equals timer. I think I cannot call it timer. It will timer 5000. So it will emit first time after 5 milliseconds, and then emit every 1 second. And we just want it to be called 4 times, because it will work indefinitely by default. And then we create our current value. We create our subscription, and then we subscribe to our timer. Subscribe with the next. Here we can do some assertions, and on complete, how long do I have? Done. I think that's all. So for more examples, you can ask me later. To summarize, we learned that observables can be both sync and asynchronous. There are 3 ways to test them: async with done function, fake async when we manually control time, and marble testing, which is more visual. Thank you for your attention. If you have any questions, I think we don't have time for them. But you can find me on Twitter. Okay.
Hello, hello. Piotr, did you have something you wanted to say? Yes, not really. Okay, checking. This is my new best friend over here. I'd like to thank Piotr Kowalski, Katarzyna Grabowska, and Piotr Zgentara for organizing, again, a fantastic meetup, and I hope the information that you receive is going to be very valuable for you. Our next speaker, and also I need to announce that there are some upcoming workshops coming very soon this month. In fact, let me just see which ones they are. We have on the dates are important, so let's see what we got. Okay. On the 26th and 27th, oh, okay, that's not the workshop. My goodness, this information, the way that it's organized in my head is very different from the way you organize information. So we have workshops coming up on the 25th of this month. We have Jak użyć legacy code. And on the 22nd of September, użyć, dobrze powiedziałem? Thank you. And on the 22nd of September, wyprowadzenie do JavaScriptu. And for those workshops, you can register later. However, also, we have a masterclass coming up on the 26th and 27th of Sherpian this month. And for this, you can get a 10% discount if you go to, which website? If you go to Confront.js, no, WarsawJS. This for me is like a big mystery. We have WarsawJS, Confront.js, and is there a third one? No third one. Okay, if you go to WarsawJS and you enter the code JS60, you can get a 10% discount on the masterclass, which will be, once more, on the 26th and 27th of this month. So that's soon. Okay, our next speaker, you ready? This is, I have his name down and everything. Krzysztof, another Krzysztof Kaczor, and his theme is Bulletproof front-end apps. Whenever I hear front-end, I always want to go like this. Bulletproof front-end apps. Krzyszek, proszę bardzo.
Okay, how about now? Can you hear me?
Yes.
Okay, great. Hi, I'm Chris, and you might know me from organizing a Warsaw TypeScript meetup. It's not a paid advertisement, so I hope that the guys won't throw me off the stage. But we do have TypeScript meetup in Warsaw, and if you code in TypeScript, you're all invited. And let me apologize in advance. I'm not a native speaker as our MC here, so you need to try to understand me harder, and hopefully you do. You will succeed. So, do we have any front-end developers here? Any front-end? Yeah, someone who wrote a CSS line in there. That's what I thought, 1 or 2 people. So that's great, because today I'm going to talk about bulletproof process for front-end development. And it's great that that the first speaker talked about tests, because I'm gonna talk how tests are not enough to write front-end applications that don't crash on production and just bugless front-end applications, let's say. So let me start with sharing a personal story with you. So some time ago, I was leading a front-end development team consisting mainly from junior devs. And to make matter worse, it was a highly complicated project with blockchain and all of sorts of modern technologies, and I was the only senior developer there. And my biggest problem, my biggest pain point was that I was spending a lot of time doing code reviews. Like, despite the fact that team members were learning, catching up pretty quickly, I was like spending 50% of my time, just reviewing other developers' code. And I was like, God, I wish that there would be an automated way to, do these checks for me. And despite having end-to-end tests, unit tests, and we also use Danger.js for sort of code review automation, I was still like spending lots of time just reading code. And I was like, there has to be a better way. And this is how I got the initial idea for CodeChecks platform, which is an open source framework ecosystem for developing code review automation. So let's focus on development for front-end apps. So let's define some of the pain points that we can have during development. You know, the things that cannot be covered with tests. So first we have visual changes, and maybe I should say unwanted visual changes, because you know some changes are 100% fine. So we all use CSS, and we all know that CSS is not that great technology, and often, you know, one small change in one place of style sheet can affect in mysterious ways some other views that we weren't even thinking about. And the situation got much better recently with new approaches like CSS modules or CSS in JS, which kind of isolate the styles to isolate the impact to one component. But still we do have like various components that can be presented in different views in a little bit different way, in many states and so on. And to keep track of all of these states, we can use something called visual regression testing. So this is a well-researched topic. And the idea is basically that we can make screenshots of our application and then compare them after introducing some changes to styles or to you know, HTML, React components or whatever cool kids use these days. So basically we have two screenshots that we can easily compare, you know, pixel by pixel, for example, or there are some other strategies that have some tolerance. And basically we can highlight all of the changed pixels in the way that reviewer has very easy job, you know, reviewing them. And so what we would expect from a visual regression tool these days. So first of all, we would want to make screenshots in many different resolutions. So for example, you know, we all do responsive designs these days, right? So we don't only want to make screenshots for desktops, but also for, you know, mobile devices and probably few other resolutions like tablets or smaller mobile devices or bigger, and so on and so on. Furthermore, we want to have different source of the screenshots. So do we have people using Storybook here for React or Angular or Vue? Yeah. So we have this libraries like this tooling that allows us to easily develop components in isolations. And this is Storybook, these are style guides or a few others. And basically we can develop a given component in a total isolation, create so-called story. And this is a great candidate to just automatically make a screenshot of, and we can also make the screenshots in few other resolutions. So that's fine. If you use already storybooks, this is the very good way to start with visual regressions. And then, but still, like storybooks tend to you tend to create stories for isolated components, and then if you have end-to-end tests, like using Cypress or Puppeteer, you could make screenshots of whole pages where you see, you know, all the components playing together and so on. And the idea is that with end-to-end tests, you're already, you know, logged in, for example, to your application and so on, so you can easily reach the states of the application that would be hard to reach otherwise. Yeah, and that's more or less how you could do visual regressions. And then another pain point is bundle size regression. So we all know that Node developers love small reusable chunks of JavaScript code that we just push to NPM, and then we're bragging about, you know, thousands of downloads and so on. The problem is that these small reusable components are not necessarily often that small. And that's why we have all of these memes about Node modules being super heavy, and, you know, you can find super weird things in your Node modules. I guarantee you that there's at least few megabytes of JSON fixtures right now sitting on your notebook in your node modules because people don't use git npm ignore and just push everything like test to npm and all of these things. But anyway, we have bundlers like Webpack to prevent us from pushing this unused code to our production bundle, right? So you could say, oh, that's easy, right? But not really. Even with create React app out of the box, you get tree shaking, which doesn't really work. So basically, for example, if you use Lodash library, I think that you should use Lodash. The problem with Lodash is that when you import one function, you can end up importing whole library, bringing it into your bundle, and this is really not needed, right? And good bundler could detect this and do so-called tree shaking, so you will just take whatever is needed from this library instead of bringing the whole library with you. But anyway, it would be cool to measure how bundle changes from commit to commit or from pull request to pull request, and detect these problems early on and fix them while they are on separate branch. And then we have all things related to performance, accessibility, and search engine optimizations. Basically, stuff that Google Lighthouse can audit automatically for us. So, have you heard about Google Lighthouse? Who used it? Yeah, like everyone. So, yeah, you're probably familiar with this screen. So Lighthouse is built into Chrome. Right now you can go to developer tools, click audit, and you get after a while you get this report. So Lighthouse can track a few different metrics like performance, accessibility, best practices, and some others. And you're gonna get the actionable feedback. Like for example, your page doesn't do this and that's why your score is a little bit lower. So we wanted to make an automated way to track these scores and prevent them from going down, because often there's very easy. It's very easy to just make a mistake and make this score drop. And the way to enforce all of these things is within pull requests, in my opinion, at least. So you probably are all familiar with this screen. This is a GitHub interface where you created pull request, and you scroll down, you have a status of this pull request. And usually you use CI. Who uses CI here? Yeah, that's what I thought. Almost everyone. So usually you have a couple of jobs like tests, end-to-end tests, linting, formatting, and so on and so on. And all of these tools are great, but the problem with them is that they give you sort of Boolean output, like either they pass or they fail. And the problem is that they can pass, but still they're lots of shades of green, let's say. They passed, but your CSS change totally destroyed the main page. But your end-to-end tests are happy to pass, right? So what CodeChecks provides you is giving you this superpowers during code review process. So this is the same screen on GitHub, but with many different metrics that we very easily added. I'm going to show you how to do this, and we track constantly during development process. So we cannot just push something to production which breaks the main page, because we would spot those problems immediately during pull request before they reach production. So CodeChecks connects with, works on different CI environments. So it can be Travis, it can be Circle CI. In future, we're gonna support many others, and and currently it works with GitHub, but also it can be agnostic to the place where you store your source code. So it can work with GitLab or Bitbucket as well. What really excites me about this project is that what you're gonna end up with is each plugin is just an NPM package that is open source. Everyone can contribute to. Everyone can fork and make their own check that does something a little bit else. And at the end of the day, you use declarative config called CodeChecks.yml, and you just put all these code checks together and pass them some options and so on. We're gonna dive into it now. So talk is cheap. I'm gonna show you how this works in real world. So we have I created like a small app based on Create React App, which is większy font. Okay. Can you see this? Yeah. Hello WarsawJS. That's all. Like if you can't see it, don't bother. It says only hello WarsawJS. And this is my terminal. This is my other terminal window. And let's browse the source code. So can you see it? Probably. I need to also change colors. Color. Is it better? Okay. It's worse for me, but if it's better for you, then okay. So we have very basic app component, which it's just a React component rendering some basic things. But what's interesting is this project has already CodeChecks set up. So in this config, in this file CodeChecks.yml, we're gonna describe what we want to track, which kind of metrics. So first, we're gonna do visual regression based on routes of the application. So this is a very simple application, so we don't need to employ Cypress or any fancy end-to-end library, end-to-end testing library. We're just gonna say that here's our build, and these are the routes that we care about. In this case, we're just gonna care about index route. So that's very simple. Then we have a Lighthouse plugin called Lighthouse Keeper, which only takes a build path as an argument, and it's gonna serve your content, and it's gonna run automatically a Lighthouse report for you. It's gonna generate a Lighthouse report for you. And then we're gonna track build size. So how what we serve to the end user is changing over time. So in this case, we're saying that we're gonna here are the glob patterns that we care about. So we're reaching inside of build directory, and we're tracking JavaScript files, we're tracking CSS files, and SVG as sort of like separate categories. So we're gonna get like the breakdown of each category. And we can track both gzipped, here is gzip size. So this is what really ends up being, served to the user, and without gzip. And we can also set up some hard limits, like for example, the JavaScript code that you're sending to the users cannot wait more than 1 megabyte, and it will automatically fail the build if it does. And as I mentioned before, these checks are NPM packages, and you can see it in dev dependencies. There's a shared CodeChecks organization, and all of these CodeChecks are open source repositories on our GitHub. And so now we have like a good test harness, like development environment, and let's make some changes to the code. For example, this looks kind of ugly. So for example, let's add a WarsawJS logo to this beautiful site to make it even more beautiful. So I have it prepared somewhere here, and let me copy SVG containing the logo. Of course, I stole it from the WarsawJS site, so I hope I'm not gonna get copyright notice from Piotr. And let me render this logo in the main React component. So first we're gonna import it, logo SVG, and we're gonna render it here inside of EMG tag, just to keep it simple. So yeah, it looks even better. So now let's add a little bit of styling. So we created class, and let's just put make it a fixed height. Okay, it looks much better. And let's commit it into separate branch and see what happens. So we're gonna create a new branch. Can you see it? Yeah, I'm just doing git checkout -b. I created new branch, and I'm gonna copy all, and I'm gonna commit all of these changes with new logo commit message. Okay, and now we can go back to GitHub interface. By the way, this repository is public, so you can even create, oh shit, you can even create your own pull requests if you want to, whatever, forks, and oh yeah, it's here. So I'm gonna create a pull request now. And you can see already that CI started building things. And one of the secrets of CodeChecks is that CodeChecks are being executed as part of your CI pipeline. So if you go to Circle, I'm using Circle CI here, but it would work in a very similar way in Travis or whatever is your weapon of choice. We have this additional task, run CodeChecks, which is just executing the client of CodeChecks, which in turn picks up the CodeChecks.yml and executes all the plugins. So I need to talk now because the CI takes like a minute, so it's still not done. Do you have any questions right now? This is a very limited time for questions. Okay, we still have a few seconds. So, any questions? No? Come on, don't be shy. Yes, I can. But we're still waiting for CI. So, yeah, I guess it's gonna be, it's almost done, guys. Or not, still restoring cache. Anyway, so I'm gonna talk maybe a little bit about how does it work in the on the backend level. So as I mentioned, like all of the CodeChecks are just npm packages, and they use CodeChecks SDK, Node SDK, which connects to the shared backend component. So for example, if you want to track, do visual regression, right? You need to have a place to store the images from previous builds, store the images for current builds, and the actual comparison happens on your CI. So this is the twist that happens here. But because of this, you could make the checks themselves open source and totally reusable. So if you know the tool called CodeChecks. Do we have any people using CodeChecks here? Yeah, few people. Yeah, so this is like for tracking test coverage. So you could implement CodeChecks as an open source plugin that anyone can contribute to. And I'm really excited about this possibility because CodeChecks is always like closed open source. And even like they're sending you sometimes shitty emails and you cannot do anything about it. I mean, other than going through UI and turning it off. It would be awesome to make a contribution and make it default to off, right? And things like this. So there are really exciting possibilities in my opinion. And okay, the CI passed, and now we got the report of changes. And we see that there are the CodeChecks that we defined materialize themselves in GitHub interface, directly in GitHub interface. And we can directly immediately spot that Lighthouse is screaming at us that we decreased, by adding the simple change, we decreased 3 metrics, so probably something's wrong. We can see that the bundle size didn't increase that much. So I mean, 2 kilobytes for logo, I think it's fine. Even though the logo could be further optimized and could be decreased even more, and we could spot it in the stats as well. And we have changed 2 files on 2 views really. So let's go into details and see what's happening. So let's start with the Lighthouse report. So we can see that accessibility metric decreased a lot. Can you see? So we can track all of these metrics here, and we can see that accessibility decreased a lot, and SEO as well. And if we click see details, we're gonna see detailed report generated by Lighthouse for us. Okay, now it's probably a little bit better. So by having this directly in GitHub interface, we can immediately spot the problem here is that we forgot alt attribute on image tag, and later, yeah, this is the same problem. And later we can spot new problem, which is the content is exceeding the viewport on some of the resolutions. So Lighthouse warned about it for us. And then yeah, let's quickly take a look at size code check result. So here we can see that there's just bundle size increased a little bit, but that's fine in my opinion. And let's go to the visual regression report, which is presented in this way. And here what we see is what how the given screen looked before, and how does it look now? And this is done for the same view multiple times because we have multiple resolutions. So we can click on it, and we have even more fancy, tools to realize what we changed. But in this case, the change is obvious. But what we can spot here is that mobile view is totally broken, right? And which was probably expected after putting like a fixed height in CSS. But again, like for reviewer, if you're reviewing, like 200 lines of CSS, this wouldn't be obvious as well. So here, like we can see that simple change would broke our application in at least few ways and decrease the final output. And so let me fix quickly the change that we made and make it a little bit better. So instead of fixed height, we can do something like this. And so now we can see that it's gonna, yeah, it's responsive. 5 minutes, right? And we're gonna add alt tag. Probably this description sucks, but anyway, I'm gonna fix Lighthouse and visreg. Okay, so we're not gonna wait for CI again because it's gonna take us like 1 or 2 minutes. So I'm gonna just proceed with presentation. It's doing its magic. And so as I mentioned, CodeChecks execute directly on your CI and communicate with shared backend component. CodeChecks is a GitHub application, so to start using it, you need to authorize CodeChecks up to given repositories directly on GitHub interface, and then copy a special secret directly into your CI environment. We have an app, web app, that gives you the secrets. You can go directly here to GitHub interface and install CodeChecks GitHub app on given repositories. I'm not going to show you the whole process, but it works, trust me. And at the end, you're going to get like feedback directly to GitHub, right? So CodeChecks is an open ecosystem. Everyone could create their own CodeCheck and use the shared backend API. And we have actually people doing this already. So I'm focusing on like front-end related CodeChecks. So if you have any idea for other, things that could be tracked during front-end development, let me know. But there are some people that use CodeChecks into totally different spaces. Like for example, you can use it for, I don't know, tracking Docker size images while you're doing backend development. But what's interesting is that the guy from the internet created a CodeCheck to track the cost of executing code on blockchain, Ethereum blockchain, because then every single line of code costs you money, real money, or funny internet money called Ethereum, and basically, developers strive to make their code very gas optimized. It's called gas, and with this tool you can track how much does it cost to execute every single function in the smart contract code. And so I think about CodeChecks as a missing step between continuous integration and continuous deployment, something that allows you to do reviews with confidence and do it quickly. And in turn, finding these bugs before they reach production branch saves you not only a lot of time, but also lots of money for your business, because fixing the bug, which is just on branch that developer is working on currently, is super cheap versus fixing the same bug when it reach production, right? And by bug, I mean accessibility problems are also bugs for many people. So that's why I have this very generic definition of bug. And I guess the CI is now done. So we can see that actually we fixed Lighthouse problems. We still have 2 visual changes, but because of course we changed the screen, but now we can easily say that, they look fine. And with this level of confidence, we can finally merge the PR, knowing that we're not gonna break something, meaning our production, too easily, or stage environment, hopefully. And that's it. I have a few pointers here. So go to codechecks.io if you want to get all these links, and you can follow us on Twitter. You can check out GitHub, because most of the things are already open source and others will be open sourced soon. So the idea is to open source the backend component as well, to create like very open ecosystem for. Okay, that's it. Thank you. Any questions?
Yeah, of course. I'm impressed, and of course now I understand everything. Now I know everything. When I came here, I was completely stupid. But I'm gonna walk around the room. Does anyone have any questions for Krzysztof? Any questions about this CodeChecks? I'll come to you with the microphone. Anybody? Questions? Here we go.
So yeah, you've mentioned that it's a GitHub app, so it integrates with GitHub via the API access. What about code privacy? Like if you're developing your own code that's super private and you're doing everything on premises, how can you securely deliver the code, and does it keep the code itself secure?
That's an excellent question, because CodeChecks don't store your code. We're not storing your code unless, if we would do a code check that does things like like CodeCoff, then probably you would need to store the code on our servers. But currently we don't store the code. We just store the minimal artifacts that describe, the execution. So for example, for Lighthouse code check, so each code check just uploads to our server different things. So for example, Lighthouse report, Lighthouse Keeper code check uploads like JSON describing the metrics. So, the performance score was like 50 and accessibility was 80 and so on and so on. And that's it. We don't need anything more to compare the results, and also the HTML report generated by Lighthouse is itself uploaded. but that's it. Like no code is being uploaded to our servers, and this was like a very very definite design decision, and I didn't want to end up having source code on my servers, right? Obviously, and yeah, that's.
Any other questions? There you are. Here I come, biegnę.
Okay, so I have a simple question, not really related to the code, but I understand that that wasn't your main motivation to make money on it, but the servers aren't gonna pay for themselves.
Yeah.
So how do you make money on CodeChecks?
This is another great question. So the answer is that even though I want to make open source ecosystem like thrive and build upon it, there are still various ways of making money. So GitLab embraced this open core model where you open source the backend components, because this is really about backend components, right? Like everything else can be outsourced, open source without any problems, and already is. Like the SDK is open source, and there are already like community contributions to this part. But the backend component will be probably open source, but not like fully. Like there will be some proprietary parts that are not essential to run CodeChecks, but are probably essential to run them at scale. And that's why and also like it's just easier to use something that is maintained by another company that you don't need to worry about. You don't need to worry about the servers and so on and so on. And that's basically the hosted version will be paid for private repositories. So also this is important. Like for public repositories on GitHub, it's going to be always for free. So you can already use it without any problems. And if you want to check it out for private repositories, it's currently in private beta with few companies testing it. And yeah, you just need to talk to me or send us an email.
Did everyone understand the answer to that question? How do you make money again? Wait, hold on a second. We have another question right here.
Yeah, so at the end, if I have, in my company, we are having our own GitLab, we won't be able to install it at this moment.
I mean, currently, it doesn't work with GitLab, first of all. So GitLab is on the roadmap, but GitHub is much more popular, and I want to start making money and then, reach all this like long tail of customers. But basically what you could do is you have two options. Either assuming that support for GitLab is done, which will be at some point. So you can take the, Docker image that we're going to create for you and just run it on your infrastructure. And you should be fine with that. Probably there will be some rough edges around the management of old artifacts. This is probably the part that's not going to be fully open source. But if you want to spend some operational effort on making it running for a long time, that's fine for you. But what you probably should do is just pay some extra bucks for on-premise deployment, where you're going to get all the proprietary parts, and that's going to work totally on your servers. I think it's exactly the same as CodeChecks. It's not like I invented it.
Questions? Anybody else for Krzysztof? No more questions? So you guys really do know everything now. I was just kidding. I don't understand a single thing. Your language, your terminology is difficult to understand. But let's give Krzysztof another big hand, please. Applause.
Thank you.
Excellent job, of course. Especially, very interesting questions. I can follow the line of reasoning with the questions. It's just that as soon as he starts using anagrams and abbreviations, I'm gone. I'm just completely lost. You guys are amazing. Okay, before we introduce our next speaker, I should announce to you that in a moment I'm going to disappear because it's going to get dark, and you're going to see only shirt and teeth. So, could happen, has happened before. after our next speaker, we're going to be inviting people to make what we call lightning talks. That means a 5-minute presentation. If you're interested or you have something that you'd like to present after the third speaker, please see either Piotr or Kasia. Okay, but this is important because we, of course, are very interested in your feedback, everybody. This is a group participation interactive. All right. Also, I need to mention again, for the next Confront.js, which will take place in December, you can get a 60% discount for the next 5 days only if you buy the pre-early bird tickets, which you can find at confrontjs.com. And we encourage you to do that. 60% discount, that's a lot. That's a huge discount. In addition to that, the master class, which will take place on 26th and 27th of this month, and that's soon. You can find the link to that at meetup.com or at WarsawJS Slack. Okay, so to get informed, please do that. The code there will be WarsawJS 60. It's all in one. WarsawJS 60. One word, small letters. Thank you very much. And finally, you done? All right. This is going to be the true test of my Polish. I know, exactly. I'm holding my breath as well. Grzegorz Tańczyk has in his description of his talk, it says, w jaki sposób, here we go. This is the reason why I am happy to be a native speaker and that I don't have to speak Polish. W jaki sposób zoptymalizowaliśmy ładowanie boardów w Jira Software 8.0. Momencik, once more. Zoptymalizowaliśmy. Tak. Chodź. Come on. Grzegorz Tańczyk, proszę bardzo, zapraszamy.
Test. Jak wyglądam? Dobrze? Can you hear me? Okay, one moment. Okay, hello. My name is Grzegorz, and as you can see on this list of keywords, I have some experience. I was working for some companies on some products in different roles and technologies, and I was also running my own business. My presentation is related to the work I was doing for Atlassian in Jira team in particular. Okay. Where I was a developer and a team leader for 6 years, starting from Jira 6.1 until Jira 8.4. As you can see, my name is mentioned on credits, and I'm quite proud of it. I'm also in top 10 of Jira committers, and yeah, that's enough of my self-promotion. I'm not sure if you know, but it's worth to mention that Jira Software was not created by Atlassian. Actually, it was called Greenhopper in the past, and it was created by a marketplace plugin vendor called Pixis, which was acquired by Atlassian in 2009. Other important date is 2013, when Jira Software went through a major redesign and new features appeared in this product. Then we have 2016 when next-gen boards appeared in Jira Cloud. And finally, we have Jira Software 8.0, which is topic of my presentation. So Jira Software is a powerful tool. It's full of features and configuration dimensions. The most popular are like here, Kanban boards, Scrum boards, backlogs, sprints, epics, versions, custom fields, reports. Other important feature are dev integrations. So this thing which allows you to see some information from tools like GitHub or Jenkins on your issue page. What else? With those features, you can create a workflow, like whatever you want to have. From technical point of view, Jira Software is a plugin to Jira. It's a solid piece of software. There is a Java on the backend, Apache Lucene for search, SPA implemented in a backbone style, but it's not using any modern framework. It was modernized over years, and what's most important out of it, it's a billion-dollar business with over 65,000 paying customers and millions of users who are like dealing with Jira every day in their work. At the same time, Jira is a source of frustration for anyone who is forced to use it at work by their employer. So Jira can be slow or even very slow, and we are speaking here about minutes for some actions like page load. And that's how our project started, the project of my team. A PM comes to a room with the idea of making agile boards fast. The 3 seconds was actually code name of the project and also the goal, so to make it happen. So my team started from very simple question, why agile boards are slow and what it means. Like research was done in 2 parallel streams. One of them is synthetic tests, where we dig into the code. We are using profilers. We generate random data sets. We run some performance tests. And the data analysis stream, where we look at real analytics data. We ask customers directly about details of problems they have with Jira. We look into support tickets so that we learn more about those real cases and maybe even try to incorporate them into our synthetic tests. So, obvious question. I think I missed some slides. Sorry. Anyway, obvious question, like, is it getting slower with number of issues? So on this chart, you can see that, which is based on real analytics data, you can see that there is like clear connection between number of issues and the load time. And we are looking here at the ready for user metric. So ready for user is the it says how long it takes until the user will be able to do the work on the screen. So the same observation for Scrum boards. They are also getting slower with number of issues. The same thing happened to backlog view. You also see the trend, the correlation. So how to fix problems in 3 months with just few people, because my team is quite small. Whenever we encountered a pattern, given this limited budget, we needed to prioritize the work and decide on how we should fix things and what should be done first. So whenever we encountered a problem, we could like optimize the code, like for example here, implement virtual scroll, or we could just ignore the problem because like it's a problem with third-party apps and like we don't want to do anything about this because it's a separate problem. Or we can change the user experience because maybe the current one is like not performance friendly at all. Like as an example, it's a pagination, something very simple. So as you can imagine, Jira is a complex software with many problems, many areas, many possible solutions. And there are like two guiding principles for projects like this. First of all, you need to create value for your customers, like it's most important thing. But then you need to ship it. So if you have some improvement on a branch and it's not released, it doesn't matter at all. So we prioritize our work using this simple methodology that we want low-hanging fruits first. Like this is low cost and it gives us most value. And then once we do that, we move towards more ambitious stuff. Like we rather avoid projects like let's rewrite the thing from scratch because they are risky and rather not doable in 3 months with few people. So now I'll go through a list of 10 problems and solutions. Those, like, I will describe them in kind of low resolution because of time limit. So if you have questions, feel free to ask, and interrupt me. So the solution for the problem mentioned before with large boards was not about implementing virtual scroll or progressive loading, which would be risky for many reasons. Instead, we have different user experience now. So for Kanban boards, we just hide old done issues. So whenever something is in the done column and it's older, by default older than 2 weeks, it just disappears. And for Scrum backlog, the solution you can see here is that we just show 100 issues on the board, on the backlog, and hide the rest. Everything here is configurable, and you can even disable this behavior. But like those improvements from this were significant, and I will show you the numbers at the end of my presentation. Days in column feature. I'm not sure how many of you know about it, but those dots, they indicate for how long this issue was in this column. So the algorithm behind this is quite complex because you need to iterate over all transitions in the history for each issue. So if you have like 1,000 issues on your board, it will happen on each page load or each reload. And then you need to aggregate this number. So like this problem was detected thanks to customer who did the work for us. As you can see, the profiler output, they proven us that this is the problem and we should do something about it. So the solution was to just disable this feature because no one was able to explain why we have it in our product, why. And I'm alive. So, and we couldn't measure if anyone is actually using it because it's on the screen. So we just disabled it, and obviously you can bring it back and keep using it. For now, we didn't hear about feedback about this, and we don't see evidence in analytics that this is actually something needed by anyone. Board picker feature. This thing allows you to switch between boards in the same project. So you can have Kanban board for some current issues, and you have a Scrum board for long-term stuff. And from one of our customers, large telecom company, we know that this single thing cost page load for them is on average 3 seconds. And because of this thing, they measured that this thing is taking 1.5 seconds, just because it's here. So the algorithm behind this is not that complicated because you just need to iterate over all boards on the instance, and it can be thousands of boards because that's how it works with Jira. And then you need to parse the underlying JQL filter. Then you need to check if this filter allows the current user to access this board, and then you can output this. So it cannot be cached at all. It's not possible. So the solution here was to just lazy load that after click. And we have evidence now that after deployment of this change, this large tele company, like they noticed improvement from 3 seconds to around 1 second, and it like affected entire instance, like this simple feature. jQuery-based colors is actually a cool feature because it allows you to display this border on left using filters. So you can say that all issues which are assigned to you can be red, and everything that is old can be black. So unfortunately, the underlying computation is quite heavyweight because it depends on the user, so it also cannot be cached, and it can be obviously like this is a simple query. Like current status is not empty, voter is current user, but like users, customers are very creative here, and they create very crazy shit, and a lot of it. So it's a performance challenge. And so at the same time, there is this observation that you don't really need this color to do your work. Like you can open the board and probably see the current sprint status, or transition the issue from to do to in progress, and it can be loaded later. So we are actually, as you can see on this animation, we are loading it now lazily, and also using intersection observer, we are loading colors only for those issues which are actually in the viewport. So it's like a huge gain. The next thing, like going a bit like low level now, just using profiler in Chrome on a board with large number of issues revealed major performance bottleneck, forced reflows during JavaScript execution. That could take seconds on a MacBook Pro. So various features are triggering this behavior because they want to adjust their content, position, or dimension. So and like this is like a almost full profile, and as you can see, there are at least 8 of them who are doing it, during the page load. So an example of such feature is this project key truncation. So the card is like the dimension of cards are changing, and sometimes the project key is like too long, and we want to fit it into the card. So in order to do that, in the old implementation, we render the board like first, then we get dimensions of single card, then we calculate the approximate dimension of single character, and then we render each card with truncated project key. So now, instead of all this magic, we are just using CSS with text overflow and flex shrinking. And like as a bonus, now you can also copy this issue key because previously you would copy these 3 dots. Now you will get full issue key. Another dimension in our data revealed yet another problem. Epics and version panel. They were affecting the performance. The problem was also visible in Profiler. A lot of time spent on JavaScript execution, forced reflows, and other stuff. But like the analytics data is most useful here because we see that like more epics, slower board. Like it's quite simple, and then it's confirmed by synthetic tests. So the problem is quite complex because first of all, it takes a while to like gather all this data, count those numbers. There are also some bonus features like links to Confluence pages. And other problem is that the underlying DOM structure is quite complex. So yeah, sounds simple, but the solution was to lazy load it. And also, like on this screen, you see that they are collapsed. Before, like for 8 years of Jira Software, actually 10 years, still this would be rendered. Like first of all, we would execute the code on the backend, and we will also render that and then hide it. So like something like this was in the billion-dollar product for years. Now we are just lazy loading that. So sounds quite simple, but like huge impact as well. yeah, this is the animation of lazy loading. Like nothing special, but like huge impact on the product and like millions of users. Resources, the bundle size mentioned on previous presentation. This was the elephant in the room, because like everyone knows that animation start. Everyone knows that there are megabytes of JavaScript and CSS resources on this page. Like, but over the years, no one bothered to do anything about it. So we were downloading megabytes of JavaScript, CSS code, and on some environments it would take seconds. So we wanted maybe not to fix this problem, because still we need to load something in order to show the feature, but at least try to get some seconds out of it. So using code instrumentation, we are able to generate a list of JavaScript and CSS files which are loaded on the page, but really are not participating in anything. So neither in page load or any like interaction, even like later interaction. So as you can see, like out of 900 files, we removed half of them. And thanks to code instrumentation, like code instrumentation is a topic for separate talk, but thanks to that, we could just safely remove them, because we knew that no single line from this file is being executed during the interaction. Or we could dynamically load something on some actual interaction, like click on some button or something. The next topic is the main request for board data. So contents of Scrum and Kanban boards and backlogs are provided by single REST endpoint, which will give everything that is needed for rendering, like issues, epics, versions, everything, including details like avatars or labels. And there are two problems with this request. First of all, it may grow in terms of size, and on some internet connections, it will take a lot of time to download. I will cover that in the following example. But the problem which I want to highlight now is the moment when it is being executed. So as you can see, we started the page load here, and we are downloading something. There is also some JavaScript execution happening here, like we need to initialize the application, do something. Then there are some additional requests. And then after 10 seconds, we ask for the board data. So the solution to this problem came from Trello team, which is part of Atlassian since 2017. They called it quick load. And the idea is very simple. Don't even try to read that, but we just want to fire this request from an inline script, which is located somewhere at the beginning of head section. And later, once the application is loaded and initialized, we will just make use of the data. And as a like result, it also makes sense to start the computation like on the moment when user clicks a link or uses a bookmark or just will open the browser. So it makes sense to start it here, not here. And as you can see, it's actually happening now that the data JSON is being requested at the very first moment of page load. Unfortunately, browsers still would prioritize some requests, and especially style sheets have the priority. There is a way to hack around this problem, like flush the first bytes of the document of the head section and force the browser to do the request. But it's like an unreliable solution, and we are happy with the current one. Now the size of the board data. This is also a kind of elephant in the room if you look at it. Like this is the epic field. So what we have here is the epic name, epic description, color, and something else. And like this is being repeated on every issue on the board. So, and this is just epic. The same thing was happening for statuses, for user avatars, for many other entities. And the solution here was to basically normalize this data by just, so in the issue object we have a epic ID, we have a thing like status ID, project ID. There is also something about user, and then in like a separate object store the dictionary of ID and the details. And like on our synthetic dataset, which was generated randomly, like this, let's say, simple change reduced the size by 50%, which is like a lot. I know this is a JavaScript meetup, but why not a backend problem? So every board in Jira has a underlying jQuery query. So it means that you can select a subset of issues which will appear on your board. And customers can be very creative when it comes to complexity of those queries, as you may guess. This is also a performance challenge. But what's worse, there is also a hidden part of this search. Like you see this as a user, but what's happening actually, we are adding a subquery, which is called permission query, to the main one. And it's generated from all projects which are on your instance, actually. And for each project, you can also define something which is called permission scheme, where you can say that users can see only those issues which they created. I think it's mostly useful for like IT service desk projects. So this subquery can grow to like thousands of conditions, and it's a huge problem. And for boards, we were able to do some observation. Like usually, you want to have a board and you have a project. So usually, this query looks like this. And the idea was that we can basically remove the rest from the permission query. And because of that, we don't spend time to generate those conditions. We also have faster search. Like this sounds simple, but still, this suboptimal implementation was in this billion-dollar product for 10 years. As you can see on this chart, which was generated using synthetic tests, we are running searches and we are adding projects. And as you can see, the red dots represent, let's start from orange dots. They represent the old implementations. So basically, search time is going up as we are adding new projects. And the new implementation is mostly horizontal. It goes slightly up because we are also adding new issues together with projects. So like this growth is expected. But still, it's a huge difference. Now, there are other improvements in Jira 8.0, like platform upgrade, where we upgrade many components, including backend and frontend stuff, and removed some code depth. There were also some minor optimizations targeted at large customers. And like what's maybe significant is new version of Lucene, the underlying search engine. And as you can see on this screenshot, like the number of tickets closed between Jira Lucene 3.3 and 7.4, it's 700. So like it's a lot of value which you can get from keeping up your dependencies, like keeping your dependencies up to date. Now this is a video from Atlassian Summit. A guy from business is showcasing our outcomes of our improvements. There is even a joke about coffee break being synchronized with the board load time. So before the meeting, people like click the button and go for coffee. I believe it's true. And at the end, he will present some kind of synthetic tests on a large data set. When the load time went down from 9 seconds to 3 seconds, which is what we wanted. I just want to show this animation because it's cool. Just one moment. I can say a joke. No, better not. One moment. I had a version with sound, but it was bad quality. So, so 3 seconds, 9 seconds, now, before, fast, slow, buy new Jira. That's the message. Anyway, those are real synthetic test results. Obviously most of it went down and we are happy about it and all, but what may raise questions here are those large numbers. Why would why would anyone want to have 10,000 issues in a backlog? It's not a backlog anymore. It doesn't matter what's the answer, but the most important thing here is the end user computer. So 1,000 issues will work fine on a latest MacBook Pro, but on a low-end machine, it's actually this type of performance. So it makes sense to put some pressure on your development machine when you are testing something. Yeah. So obvious question maybe about analytics data, do we see any difference? So the correlation between number of issues and performance basically disappeared, which is what we wanted. The customer feedback, we heard something. There is some feedback, but it's not as dramatic as as the synthetic test results. There are many problems with Jira in general, but yeah. We didn't expect that everything will load now below 3 seconds. That would be unrealistic. So that's all from me. If you have questions, please ask.
Wow. I'm really disappointed. I didn't get to use my gong. No, it's for me. That's all I can do is just keep gonging. I have nothing else to do.
You can still use it.
Can I still?
Yeah,
okay,
please.
Thank you. Thank you. Questions?
How do you map the user experience to the mobile applications? Because I imagine when implementing the new features, let's say improvements to the web, you've also maybe got inspired by the mobile client, or the other way around, the mobile client also implemented the new parts from the web?
So luckily, Jira Mobile is a separate code base, separate team, separate knowledge. It's not connected at all. The only connection are REST endpoints, but currently, I think Jira Mobile does not support Agile boards. Please correct me if I'm wrong. Yeah. Anyway, there was no real connection. There is no shared code base at all.
Questions? Any other questions? Okay, let's go this way. Here you go, sir.
Which part of this, what you told, was the biggest challenge to improve, to optimize?
So I think the biggest challenge was this one. This one was the challenge. You need to do it in 3 months. And with few people, this was the challenge to do this project on time, manage the people going on vacations, people getting sick. This was the problem, really, the biggest one. The technical stuff, if you look at all of that, it's lazy load, disable, normalize something, remove some stupid code, maybe even it was mine code. So yeah, the technical stuff was quite simple, I would say. The project management stuff, this is the challenge.
Biggest challenge, yes?
Yeah, always.
Someone else had it.
Okay, you mentioned that Jira doesn't use modern web framework like React under the hood. My question wouldn't be specifically about React, but generally, do you think using any front-end library that would use, I don't know, virtual DOM or something like this would improve the render performance in your case, dramatically, or
Yeah, it definitely would. But unfortunately, there are some constraints. We have third-party apps. We need to find a way to support them with React. It's not obvious. I wouldn't say that it's not possible, but it's not easy. And what's interesting, in Jira Cloud, there is actually a React single-page application, and the interactions are quite nice, smooth, and quick. But there is other challenge, like there is a 40 megabytes bundle, which takes a while to load, and it's like not easy to fix it now. So like, yes, someone did that, and someone kind of failed. So it happens.
More questions, anybody? Really? You have another one?
Yeah.
Thank goodness. You guys are really quick.
Please tell me if you use Jira for Jira development.
I do use Jira.
Thank you.
But it's very, very simple. Like, I don't configure a lot, so it's like a simple tool for me. Just comments and that's it.
That was great. That was great. I think that was a brilliant question, right? I mean, come on.
Eat your own dog food.
You didn't expect that, did you? Anybody else? Any more questions for Mr. Tańczyk? Okay. Thank you very, very much. Excellent presentation.
Thanks.
Thank you so much. Listen, before I give the microphone to Piotr Zientara, I think he's going to be interested, if anyone has any lightning talks, anything quick that they're going to want to present, you're going to need to go through this man right here. He's going to direct the traffic. But before that happens, I have to again remind you of a couple of events. First of all, the procedure for registration for the upcoming workshop on the 25th of this month has been slightly changed. That means there'll be no more selection, and the ticket which you buy will decide which group you will join. So there are 4 groups and there are 4 levels. So it's important when you buy your ticket to specify which group you would like to register for or belong to. Secondly, master classes, 26th and 27th of this month. That's coming up right away. You can, I understand, get a 10% discount if you go and register immediately, and the code will be WarsawJS 60. Those things are happening immediately, like soon. So we encourage you to get out and get involved. I'm continually impressed by what you do here. One of these days, if you keep me around long enough, I'm going to figure a few things out, and I'll be able to say something intelligent. But until that happens, I'd like to again thank the sponsors, 10 Clouds, Daft Code, L Passion, Sumo Logic, and Schedule. In addition, I'd like to thank the organizers again, Katarzyna Grabowska, Piotr Kowalski? Naprawdę? Cały czas mówiłem Kowalczyk, nie? No ja przepraszam, no to jest tak, przepraszam, taki błąd, oh my god, idę do domu już. I Piotr Zientara, oczywiście, mój kolega. So before the next part happens, this is going to be lightning talks. Lightning talks. These are 5-minute presentations, and I'm going to hand the microphone over to Piotr Zientara for this. Yes, because he's going to. You don't want to. Okay, let's go. I mean, I thought it would be a good idea. It's just nice to see your face and everything.
Thank you very much, Barry. So, also big applause for Barry for today. And the first lightning talk is will be by you. So please, you can come already. Oh, by the way, after this lightning talk, we will make a raffle on WebStorm or a different JetBrains product, because it's our partner and it's going to hand out us the gifts for 1 year of a subscription, which is quite generous. I think so. Two of these will be just very soon on the raffle. Is someone interested? Hands up, please. Okay, very good. Very big chance for big chance for winning. Okay, so 5 minutes.
Yeah, 5 minutes.
Okay, let's start.
Okay, so first question: how many junior developers are here? Oh, quite a few. Okay, it's a presentation especially for you because I am a junior developer myself. And last month, our colleague told about the imposter syndrome, told about how he trying to fight with it. And I also started to think about it. And actually, the best solution for the imposter syndrome is to learn, and learn how. The best is to learn fast. And I started asking this question for myself, and because I'm still learning, I asked somebody who is more wise than me. I asked one of the best and the greatest minds of the 20th century, the guy who actually was in the age of 23. He was in the team of Project Manhattan, who creates an atomic bomb. After that, he just go to quantum computers and quantum physics. Richard Feynman, the great explainer. The method which he developed was written in this book, Genius, the Life of Science of Richard Feynman by James Gleick. And everything he touches, it's quite simple, brilliant, yet powerful. This method tells about the 4 steps how you can learn and master almost any part of the science, including development. The first step is to pick a topic you want to learn and start studying it. It's quite simple. You need to pick one thing. For example, I don't know, I want to learn React, I want to learn Vue.js, I want to learn the JavaScript itself. Yes, one take at a time. And start to learning. Take tutorials on YouTube, take some lessons, read some books, started to learn, gain this knowledge. And then comes the second step. The second step is to pretend you teach somebody else. And this is one of the most powerful part of this method. Why? Take a rubber duck, take a teddy bear, take your girlfriend, and try to. Yeah. If you like to risk, you can, and start to pass this. Start to explain what actually you learned, and you quickly realize that there are some gaps you need to fill out. But again, if you want to explain something, you need to literally hammer it in your head. And when you start explaining something, you get stuck. Definitely you will get stuck. And if you do this, get back to the materials. Get back to YouTube channels, get back to the books, and we have this inner circle. I said it's a similar like a Scrum. Yes, you just need to run some sprints, checks, and go further. After that, if you go to this point, and you can simplify all ideas, take them and say in the simple analogies, simple words, and actually you'll be able to explain everything to a rubber duck that the rubber duck will understand it, means that you really gain this knowledge and you're really a person who knows what he is or she's talking about. One of the things that Richard Feynman said, study hard. Study hard. What interests you in the most undisciplined and irrelevant and original manner possible. And he really does that. One of the greatest theories, mathematical theories he made in the strip club. So the method is just one of the methods. So you can always challenge this. But remember, when you challenge something and trying to explain, find the arguments, then you learn the most. So my name is Chris, I'm a junior developer, and I'm really eager to learn JavaScript. Thank you.
Sorry, I have to tell that. Thank you, that was great. I have some questions for you. May I ask a question or two? Okay, one. I am professionally a choreographer. Everyone knows what that is, yes? It means I plan and design movement. At the beginning, I only said I was a choreographer. So I chose an area, like you said, and I decided to go about teaching people to move. Luckily, most of my previous students still have their legs. But I was a very ambitious student who wanted to be a teacher. And your method sounds, or this method that you're describing, it sounds like it could be effective. I'm just wondering how you get feedback from teddy bears and rubber ducks.
Yeah.
That's my question.
We're living in the era of Internet of Things, so sometimes the rubber duck can speak to you, which is strange. But you can do it. I saw the rubber duck with the Google Assistant inside, and actually she was speaking something to me. So
I
that was
totally
weird.
believe you, but just in case anyone's wondering, don't try this with your girlfriend, okay? There you go. This is you. Thank you. Thank you very much.
Okay. Any other questions?
Yeah. One last question. This is a lightning talk, okay? Thank you very much.
Okay.
Thanks, man.
Thank you.
Okay, so as I promised, there will be a raffle now. Yes, but I promised after this lightning talk. So now the raffle, and then 2 more lightning talks, right? Who's else? Okay, so Krzysztof, you would like to be first? No, raffle. So you'll be first, okay? Okay. So now the quick raffle. So again, the software created by Tati made some improvements. And now it's impossible to double browse the same number, because although we had this random number, it was for among 30 different numbers, there was 3 times the same random number, and now it was so interesting that actually it probably was a random number, but appeared 3 times in a row. So, okay. I should give you numbers. So everyone who wants to have WebStorm or a different JetBrains package, number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and you remember now your numbers, and then if you win, you go to Tati. So let's browse. Congratulations, number 5. And one more. $16. Congratulations. So the last number, and now let's welcome Rafał for the lightning talk. Oh.
I don't have mine, and I need just a browser to get to my universal slides for this kind of things. Okay, can you hear me? I guess not, so I can start. Okay, my name is Rafał Puszczalski. I don't have slides for today, but I wanted to talk about one of my pet peeves, which is relational databases and some misunderstanding regarding them. So, is the audio okay? Or because I don't hear it very loudly. So, I guess something like 20 years ago, I wrote something on Usenet that People shouldn't be allowed to touch any database unless they know relational algebra, set theory, and predicate calculus. And I got a lot of hate for that, but I didn't change my mind today. And a few years ago, I wrote an article on Medium, which you can get to from my website, that there are no tables in relational databases. Because I know that there is a table keyword in SQL, but it's like, forget about it, it's not about tables. There are relations, and I remember reading a lot of times a sentence like this, that it's ironic that, ironically, relational databases deal poorly with relationships. And once I even read it in one book, so then I got really, frustrated by it, because first of all, it doesn't have anything to do with irony, but let's say that it does. And then relational databases are not about relationships, but about relations from relational algebra. And this is one of the things that I think needs to be understood, because when you don't think about tables anymore and think about relations, then you ask yourself, what is a relation? And when you just get to any definition, you get that relation is a set of tuples, and then immediately you know that, because a table is just a list of rows. And if you think about a relational database as something that stores tables, which are list of rows, then you get a lot of misconceptions, because a table has an order. There is a first row, second row, and things like that. There can be multiple rows that are the same in a table, because why not? It's like an array of something that can be with elements that can be the same. But when you think about a relation that is a set of tuples, then first of all, it's a set. So if you know anything about set theory, then you know that you cannot have multiple elements in the same set. So then you just know that it cannot be multiple tuples in the same relations that are the same, unless there is something that is distinct, like a primary key is an example of that. If you need to put, if you want to have anything that is the same tuples, which most of people would say the same rows in a table, then you need a distinct element of a tuple, which most of people call a column, but this, I want to avoid this because it's a terminology from tables. And when you know that it's a set, then you have all of the set theory at your disposal. So you can have, subsets, you can have intersections, you can have Cartesian products, and you can use all of that in your thinking about data in a relational database. So this is something, and the Polish word for tuple is krotka. I don't know if anyone has heard even anything about it, or is using it on a daily basis, but this is what most of people just don't know, and I find it funny, because this is like the most basic thing in any relational database. And as soon as you know that a relation is a set of tuples, a relation is something that people usually call table, but it's not a table, it's a relation. So it's not like a relationship between different tables or between data. It's a certain thing in a relational model, which is a set of something. So first of all, it doesn't have any order. Second of all, it cannot contain the same elements multiple times. And when you ask yourself, it's a set of what? Then it's a set of those tuples that, and really a relation is not just any set, it's a subset of something. A subset of, let's say, every possible tuple that can be there. So, and which is really a Cartesian product of a domain of every element. Okay, so I guess that you need to read my article on Medium to know more. It's called "What If I Told You There Are No Tables in Relational Databases?" So I invite you to read it. So, and if you want to talk with me after then,
Thanks a lot.
How do I put it up? Like that? Help me. Ah, okay, okay. Fine. Okay. So yeah, this is what I'm going to talk about: discriminated unions and application state. So this is the talk about Redux or Redux TypeScript, but also about Redux because it concerns application state. So yeah, discriminated unions are a term in TypeScript, but before deciphering the word discriminated, I would like to talk about unions. So how much of people there, how many people there use TypeScript? Yeah, fine. A lot of people. So you maybe you may know these terms, but still. The union is a way to combine multiple types in TypeScript. So you can have an ID property, for example, or a parameter to a function, which can contain a multiple types, and that is called a union. So here for an ID, we have a union of string or number, and this union of string and number can be saved in a type alias called ID. And in this case, we say that string and number are members of an ID type. So the problem that I'm going to talk about is the problem of overly generic interfaces. Here we have a shape interface that actually can represent a circle, a square, and a rectangle. For a rectangle, it will use width and height properties. For a square, it will use size property, and for a circle, it will use radius. And you're not sure if, for example, you get that as a function parameter, you're not sure which shape you exactly got. And another problem is that this interface allows for such tricky things as, for example, an object with a size and radius, and you cannot for sure know what shape it is. Is it a circle? Is it a square? And in that case, for convenience, you'd like to add a type property which would tell you what kind of shape it is. But another problem is that this interface allows you to have type of rectangle, but it only has radius property. So yeah, it's practically a nonsense. So here's where discriminated unions come into play. Discriminated union is let's say it's a union where members have a common property, but type of this property is a unique for each member. It doesn't make a lot of sense by just this definition. So I have some code examples which I would like to show you. Yeah. So here is the first one. Here we just deal with the shape, and here we have separate interfaces for square, rectangle, and circle. And here we here we clearly define that this interfaces have their size, for example, width and height, and radius, and these are required properties. And later we say that shape is a union of these three interfaces. Each of them has type property, so a common property, but type of this type property is unique for each member. So here we have square type for literal type for square, rectangle for rectangle, and circle for circle. Here we also have overly generic shape for the reference. So when we use shape, not the overly generic one, but discriminated one, in each case, and TypeScript can for sure know that in the case of square, we have size size property. So we compute area in this way. In rectangle, we compute area with width and height, and in circle, we use radius. And TypeScript can allow us to use these properties because it knows that in case where we have type circle, we only have radius. And if we were to use this overly generic shape, we would get a lot of type errors because these properties are possibly undefined, and TypeScript has no idea that in case of square, you should you for sure have size. So here's the more real-life example where you can use discriminated units for actions in Redux. Here we have three actions: increment, decrement, and reset, and they're constructed in the same way as in the previous example. Here we have the action union where that just combines these, and counter state. It's just for convenience I used counter state, so it's just a number, but it's obvious that it's state of a counter. And here is the reducer where you also use this pattern matching, and for each action you for sure know that you have these properties on these actions. Okay, yeah, okay. So for overly generic, you're not sure each of them are any, and for discriminated unions, TypeScript would give you errors if you have some problem. Hello, hello. Yeah, yeah. If you have a question, I think I have.
Hello. This was working. I just accidentally switched it. So who has a question?
Oh, nobody.
One question.
Oh yeah, question.
This is going to be a hard question.
No, the question is actually going to be easy. So I've used TypeScript and Redux. And it's nice defining the actions. The only problem I have, it's very verbose, because not only I have to define an action creator, but I also have to define an interface, and then I have to define the the discriminated union. Maybe there is like a magical way to reduce boilerplate.
Yeah, there is a magical way. One magical way is just don't use action creators, because it's one of the magical ways. I will show you the second. But the magic of the first one is that you don't use action creators because you don't need to use them in TypeScript. You have only type checking, and you can just use dispatch, and it will type check. It will type check if you give the right type, because TypeScript checks strings. But another way to just skip the action creator, just use classes, because you can, for example, define it in this way: class increment. And here you can say read only type increment, yeah. And here will go your payload constructor. Also read only by number. So the magic of this is now you can create action in this way. Action is just new increment. And here goes your payload, 5, for example. Why do you give me error? Parameter should not be allowed. Okay. It should work. Yeah, the magic of this is that you type this only once. You don't need to now say that the return type would be something else. Yeah, that's how you can reduce boilerplate. Also, there are a lot of helper functions, helper libraries out there that can also reduce your boilerplate if you don't want to use classes. But what this example is good, it's good because you just use classes and don't use something out or something third party. You just add 0 bytes to your bundle.
Okay.
Basically, I think even better approach is to use action creators, but put them into one huge object and derive the interface from them automatically by using return type, and then just creating huge union type of only few creators.
Here you
per
start
method.
the holy war, because
No,
because I'm really I don't think return type and type of in this case is a good thing, because here you're defining your types by implementation. So
this is the way to go.
No. Oh yeah, yeah. It's gonna
Yeah,
be
let's talk
yeah,
later.
yeah. It's not a discussion for a lightning talk. Yeah.
Please, no holy war in Poland. Please, I'm begging.
Yeah.
Thank you once again for your presentation. Fantastic job.
Thank you.
Lightning. That means 5 minutes. I'm sorry to cut you off, but we did say 5 minutes, right? Everybody's okay with that? Thank you very much for tolerating me this evening, this afternoon, today. I do have to repeat a couple of things. The ConfrontJS meeting, which will happen in December. Conference. Meeting, conference. I won't say that for me now, it's not all the same. I understand the difference. So for the conference, remember that if you register within the next 5 days as part of the early bird pre-sale, you can get a 60% discount. I still can't understand how anyone can give a 60% discount. That's a huge discount. So please go to the website. And by the way, if you go to the website and you apply as a speaker and your, let's say, theme is approved, then of course your ticket will be free. It makes sense. Also, by the way, I forgot to mention the address of the workshops on the 25th of August. Go, please, to WarsawJS.com. The address for this workshop, which is jaki Legacy Code. It's my own handwriting, it's just my handwriting. jaki Legacy Code. This will be the workshop on the 25th of August, and the address is at the Sumo Logic office on Solidarności 173. So we thank you once again, and thank you for tolerating my broken Polish and my native speaking English, and we'll see each other in the networking afterwards, okay? Mr. Kowalski. Again, I apologize. I don't know why I'm thinking Kowalczyk. I know why. I'm not going to talk. It's about, we had a series in America called MASH, and there was an officer called Kowalczyk. And this just stuck in my head, but that's another story. Thank you very much. Thank you very much to the organizers again, Katarzyna Grabowska, Piotr Gentara, and all of our speakers. Great job, everybody. Thank you very much. I did it again? Oh, no. Piotr Kowalski. No, but I know it's Kowalski now, at least. Thank you. Sorry very much.